Hi, welcome to OSPF, Open Shortest Path First. OSPF is a router protocol used within larger autonomous systems networks and is preference to Routing Information Protocol, RIP. OSPF was developed in 1991 and it was updated in 1998 to its current version, OSPF for IPv4 support. In 1999, it was updated again to support IPv6. OSPF was developed as a replacement for Distance Vector Routing Protocol, RIP. It operates as a classless routing protocol that uses the concept of areas for network scalability. OSPF uses a metric called cost, which allows it to calculate bandwidth as a metric for defining shortest path. OSPF's link state is used instead of counting the number of hops as in RIP and EIGRP. OSPF is a dimensionless metric, or can be referred to as cost with a maximum value of 65,535. OSPF doesn't add these metrics as it does in RIP or EIGRP. In OSPF, the routers distribute the individual link costs to one another. The Dijkstra shortest path first algorithm is used to process these bandwidth costs and update these in the link state database. OSPF also uses link state advertisements, or LSAs, to update changes in the network. These are sent out over multicast to all routers. These link state advertisements are also used to meet new routers to get updates about the link state database, to update changes about the network, as in failures. When one router fails to respond to the hello messages, the router eventually terminates the adjacency to that neighbor. They are sent out over multicast and are only sent when changes happen within the network, as in RIP, where they're sent out every 30 seconds. This cuts down on traffic over the network, as well as processor power. And then the information it sends is only the information for the link state database that changes, where in RIP it sends each time out the entire link state database. OSPF hello packets are used to establish neighbor adjacencies. They are sent out every 10 seconds over multi-access and point-to-point segments, sent every 30 seconds on non-broadcast multi-access segments. These hello packets are sent in order that they know that each interface that it's connected to in that router remains up and in an active state. OSPF also uses dead intervals. This is a period of time a router waits before terminating a router's neighbor adjacency. This is caused by failures in the network, whether it be physical or software or hardware based. The default is 4 times the hello interval. On multi-access and point-to-point segments, the time is 40 seconds, and on NBMA networks have a 120-second dead time interval. After this dead time has surpassed, the router will drop that adjacency and then will send out a new broadcast to tell other routers in the network that this is no longer a valid path. In OSPF, to become an adjacent neighbor, there are parameters that must match on both routers. For one, the hello interval time must match. In addition, the dead time interval, the type of network, and the subnet mask. All these must match in order for the two routers to establish adjacency. In OSPF, router IDs are used to identify each router in an OSPF domain. These are IP addresses which are configured using the router ID. If no router ID is configured, the router will use the highest active IP address of its loopback interfaces. If there are no loopback interfaces that are configured, the router then will choose the highest active IP address on its physical interfaces to use as its router ID. Next, we'll discuss area IDs. In OSPF, these refer to a network domain. OSPF area is a group of routers who share the same link state information. In order for these routers to work properly within this domain, they must all have the same link state info, and it must be received from neighbors in their link state database. In this picture, we can see the idea of areas and how OSPF will actually cordon off these areas, and you can set it to where you can only talk within that area to increase the security to allow packets that don't get sent out over different areas of a company which don't need to be sent over. In conclusion, there's many aspects that make OSPF such a popular choice among network engineers. For one, it's a classless routing protocol. Two, it supports variable length subnet mask. It also offers easy scalability and works great in larger network topologies. It guarantees a loop-free routing without having to worry about being stuck in routing loops and having issues with down network as much. And it also supports address summarization. Thank you for watching my video on OSPF.